Hello, everyone. On our last webinar, when AI agents get the key to your network, we covered quite a bunch of concepts from identity and MCP-tool access control through authorization and command control at the device level, through attribute-based access control and end-to-end auditing. Because of the vast number of concepts, we were not able to dive deeply into how the environment was set up and what were the configuration details. Therefore, we decided to split all the topics covered during this webinar into three-part series. And today, we will focus on the first part, identity and MCP tool access control. And in another part, we will cover another. But this time, we will focus on implementation and configuration details, but also we will revisit all the concepts covered during the webinar. My name is Tomasz Janaszka, and I am solution architect at CodiLime, focusing on projects applying AI and machine learning techniques to solve various challenges in network and IT infrastructure management. Let me recall the problem that we would like to solve. In the era of agentic application, when the network engineers would like to operate on network devices via applications, and those applications are using agents which are utilizing the tools offered by various MCP servers. The problem is that the users have different roles, different permissions, and what we would like to achieve is that our agents and our application that is supporting the user and is acting on behalf of them is using only their permissions and scopes. This is our primary goal. The secondary goal is also that the agents only can access the devices that are authorized for particular users. And of course, as the path from the user intent to execution on network devices, particular commands, is quite complex in that architecture. Therefore, we need to assure to have end-to-end audit trace. So we should know, in case of the incident, who did what in our infrastructure. So in this part, we will focus on the first goal. So we would like to achieve the role-based access control to tools and commands on network devices, depending on the, say, user roles. During the webinar, we presented some gaps in this architecture. So in this part, we will focus on those three. So we would like to stress that MCP protocol does not standardize the authorization of tools. So it needs to be implemented and can be implemented in different ways. And also during the tool discovery process, when we initiating various agents, there is also a need to properly tackle this problem of exposing which tools are available for particular agents. This should protect us from the problem of confused deputy problem. If we did not so, the agent do its best to fulfill the user intents, and if we do not limit what the capabilities of that agent, then this agent will try to do everything just to fulfill the intents. That's the confused deputy problem. And also can access various devices that are not authorized for particular user. So we will focus on those three gaps. And now we will be talking about how to introduce identity or to apply identity that we already have in our environment in order to properly control the tools at the MCP server level. We need to use existing or deploy identity provider that is able to model user accounts and is able to authenticate the users and at the same time issuing access tokens for particular users, embedding some necessary information that could be used by agents and MCP server to say what is allowed or not. So after the authentication, we receive the JWT token for a particular user that is being forwarded during the execution path. And AI agents and MCP server can utilize this additional information about the user, especially what are the MCP scopes describing which tools are authorized for this user. And MCP server can do it on two moments: when the tool is tried to be executed or intended to be executed, and another one first when we initialize the agent and we are registering tools for the agents, that MCP server should list the tools on available or authorized only for particular user's role. How it looks like when we open the browser and would like to access our agentic application, we will call it Net Inspector, and click login. We are being redirected to our identity provider page when the user could log in. And after positive, say, verification, the browser receives the authentication code and redirects again to our, say, application that is exchanging this code with identity provider, verifies this code, and after that, it receives this JWT token signed by this identity provider for particular user. After that, the Net Inspector, our application, should initialize the agent. So to create agent, of course, we need to provide this user token. And the agent is first must list and register tools available exposed by various MCP server. So in this way, is calling MCP server and tries to receive the list of tools. And this token allows the MCP server first to verify it using the public key from identity provider, and next to filter the tools according to user role. And after that, the agent is receiving the list of tools, registers, and could act. So in the next phase, of course, user is asking queries that are being passed to our agent. Agent is running some reasoning based on the available tools and the user intent in the query, and decides which tool to call and how to parameterize it, and request the tool execution from MCP server. MCP server then again verifies this JWT token with the identity provider using its, say, public key, and of course need to validate the tool input, whether the attributes for the tool are correct or can be used, and is applying the required scope check, which means that for each tool we have the scope which is defined, and it compares if the scopes, MCP scopes, are in this token. If all these checks pass, then the MCP server just communicate with the network devices and executes the command that is in our tool and get the response. Or if it is not passing, for instance, there is a scope that is not authorized or not devoted to particular user role, there is the denial and we got the output or error. When agent receives this output, it can decide to answer to the user or could find or try to find another tool. And that repeats to gather the final response for the user. So now we will switch to our application. I think it will be much more clear. But before, I would like to introduce that we will have three example users: Alice, Bob, and Mark. Alice is NetViewer, and MCP scopes is MCP read, which means that it could only execute the commands on network devices that are not harmful. So they are just exposing the information about the topology, interfaces, statuses, etc. Bob is net operator, and also it contains the MCP prop scope, which means that we allowing some additional command like ping and trace route. In that way, Bob has much more capabilities to find, for instance, the problem. And we have the Mark, which is netadmin, that has all the scopes, including read, prop, and write. So it has access to the full commands and full tools on the MCP server. And we will demonstrate that when these particular checks are being done in MCP server and during this tool call, tool execution, and during the initialization. So now I would like to switch to our application. We will call this Net Inspector, where when we click logging with our identity provider, then we have the Alice, and I will log as Alice, and our application starts. And we could easily see the token details for Alice. So some standard attributes of token, when issued, when expiring, what is the time to live, and user information, that is the Alice, and we have the net viewer role for this Alice, and user ID, and also session ID, key clock session ID. And we have MCP-tool scopes. When we have here the names of our MCP servers, and the scope describing which type of tools Alice is authorized for particular servers. Yeah, so this is the token just after logging, but let's say a few words about our application. It is built upon 5 MCP servers, exposing tools for the different networking context. So we have MCP topology, exposing tools able to deliver information about network topology. We have MCP control plane and MCP data plane servers, offering the commands that we could execute on particular devices related to control and data plane. And we have also MCP for hours, for MCP locky for logs from the network devices, but during this demo we will focus on those two, MCP control plane and MCP data plane, because they are directly connecting and collaborating with network devices. In different colors, we are just marking that in green color we marked all the tools that are read tools, and by red colors we marked a couple of tools that could change the configuration. Therefore, the scope, MCP scope, is right. And in MCP data plane, we also provide some probe tools related to ping and trace route for commands that are executing some diagnostic actions on network devices. So 3 different colors for 3 different, say, type of scopes. And just after logging to our application, an agent is being created for this particular user. And here we could see that during the creation, the agent asked all these MCP servers for the tool list and registered all the tools to be used during the process of answering the user queries. So here we could notice that Alice, as our net viewer, only got the tools of type read. And we have 19 tools from different numbers from different MCP servers. And user is interacting with the agent via chat. So here in this window, we will be providing some queries to our agent, and we would like that the agent would fulfill our intents and provide response about our network. But under the hood, there is a network that we modeled using Container Lab. So we have 9 nodes. It is multi-vendor, so we have various type of devices. We have Sonic, ViOS, FRR, that are spread, that have different types. So this is the spine and leaf simple topology. And the nodes are spread across 3 sites, Chicago, Denver, and Seattle. Each node has attribute describing its environment type. It is the production or lab. And also some nodes are belonging to different, say, tenants, and some of them are also shared. Here, whenever we pose a question to our agent, the user posed a question to our agent, the agent is trying to find appropriate tool or tools to execute them via MCP server and deliver the answer to the user. So this is the Alice and how it works for different users, because this is our objective. So let's now log as Bob, our network operator. Yeah, the same view, but a couple of differences. First, when we looked at the JWT token for this user, we could see that for the MCP control plane and MCP data plane servers, the user could also utilize the tools that are marked as probe tools. So traceroute and ping in our simple example. And also, if we just switch to chat, we could see that the agent for Bob contains also the capabilities for running those tools. So we have all the read tools and 2 probe tools that are marked here by the yellow color. And we will do the same for Mark, which is our net admin. Again, when we check the token details, we could notice that also all write tools are authorized for this particular user. And if we switch to chat and observe what MCP tools were registered for this particular agent, we could see that also there are 3 write tools from MCP control plane. And here we could see them as marked by the red color. I will provide the prepared queries not to waste time for writing, but first let's just ask a simple user query, show BGP summary on our, say, Sonic device. And this is the Chicago Leaf 01. So if we execute, now the process is being started. And we receive the information about the BGP summary for this particular node. But let's try to do, for instance, traceroute. Traceroute, as I marked before, it is the probe tool. It is not authorized for Alice, but let's try to run it. And this time, we should receive that tool is not available, because if we just look over the list of available tools for this particular agent, we will not find the probe tools. So the agent responded that the tool is not available. That is good. But let's check if Bob is able just to run this traceroute. It is the command, the tool and command authorized for Bob. If we execute it after a while and all the communication between MCP logging to devices and receiving the response, we should got the answer. So we could see that this traceroute has been performed on this device, and we got the answer. But let's try as Bob to run something that could change the configuration. Let's use the simple query, set MTU to some value on one of the interface on the our node in Denver, spine 01. So definitely it is the right tool. What we need to achieve, tool is not available again because it is not authorized and not listed here as an available tool for the agent acting on behalf of Bob. But our network administrator should be able to do that, because first we could see that we have appropriate tool here. It is available for the agent. Let's run the same query here. Of course, this is right. So our agent is forcing us to approve or reject execution. And here we have the confirmation that our MTU has been changed. And let's revert back to the previous value to follow the demo. So we could see that depending on the user roles and appropriate configuration of tokens for particular users, MCP server can use that information to properly filter tools and not execute tools that are not authorized for particular user roles. But one point here, what could be if we, because we are just filtering the tools during the initiation of the agents. So we prepared a special toggle here. So we would like to discover all tools. So we are not applying the tool filtration. So here for the Alice, we just provided all the tools from all the MCP servers. Theoretically, this agent is able just to try to call any kind of tool we have here. But even though, let's try to run this trace route again as the Alice. And here we should be blocked because access is denied, but this time the tool is available. Agent is trying to run it, to execute it, but at the MCP server level, it is the check if this tool is the type of probe, which is not granted for Alice. And we have the clear information here. What is the required scope and what is granted for Alice and is not provided here. So this is the denial. Of course, it is anti-pattern. We should switch off this. So whenever possible, we should filter the tools for particular agent, for particular user roles according to the scopes, because in that way we are just limiting the problem with too broad potential attack surface. But second reason for that is just the efficiency, because it is no sense just to provide all the tools when particular user is not authorized to do. So we will use much more tokens, and LLM will just reason what to do according to the intent. But at the end, there will be not be able because the MCP server just blocked these calls. So it is anti-pattern, but nevertheless, even if someone omits this part of listing proper tools, we need to, for sure, definitely to do the check during the tool's execution. So let's summarize the demo. What we achieved. So we achieved that unauthorized tools are invisible to the AI agents. And this is the double check, because during the tool execution, also the same check is being performed, just comparing the allowed MCP scope for the particular user against particular tool. And also what we achieved is the good clear error messages, whether a tool is not visible or it is visible, but it is not authorized to be executed for a particular role. So how we achieve that? We need to properly configure our identity provider, and of course to provide some code in our MCP server. So here I would like to show some implementation details. So first point that we need to do is just to prepare how we would like to construct our say MCP scope. So this is what we applied. So this is the namespace. So it concerns MCP tools. So this is the MCP at the beginning. Next is the subsystem, meaning what is the particular MCP server. And next, we define the risk level for particular tool. And inside the code, when we define particular tools in our MCP server, we just tag each tool with those MCP scope. For instance, here we have show BGP summary, which is the type read, and it is from MCP control plane server. This is the example for probe. For instance, run ping on run trace route. When we just mark this tool as a probe and from data plane. And for the tools that can change, that can be potentially disruptive, can change network state, we are just marking them as the write, And this is the example for set interface MTU in the control plane. So this is the first point we need to do developing our MCP server. And second point is, of course, we need to properly define the users in our identity provider. So first, of course, we have some standard attributes for each user, but some custom attribute. In our case, we would like to associate the network role. So net viewer is the role for Alice, for Bob is net operator, for Mark is net administrator. But inside the key clock, we need to define particular roles, individual roles for particular types of tools, and a composite role for net viewer, meaning that here we are defining which MCP server could be used and which type of tools can be used, are authorized for particular user role. And proper definition of protocol mapper would lead us just to proper shaping of JWT that is being delivered after successful authentication in identity provider. So here we would like to see how this JWT was signed, which kind of algorithm, and of course using the private key of key clock. And we here also need to embed all the necessary data as the user preferred name, email, net role, which is important, and MCP scope. So this configuration here for particular role should be mapped to proper values in JWT for the user, and of course some standard attributes that when this token is expiring, and of course who is or she should audience, all this additional check that can be checked during the validation of JWT token. So this is the second point. And of course, in code of our MCP server, first we need to verify the token. So using the public key of our identity provider. So we need to provide the special, say, method that using public key, we can verify the token and extract all the necessary fields. And whenever all those checks are not passed, then we have the unauthorized. We will not provide the access token for the further execution inside MCP server. But if we got the access token, so we are retrieving the username or user ID, scopes, and all the payload of that, and we could just implement the simple code for tool filtering. And here, as we are using fast MCP, so there is a convenient placeholder for the method filtering the tools. So it is very simple. Just we retrieve the scopes from user token, and for each tool, say in our set, we just retrieve the required scope for each tool. And if this required scope is in a set of user scopes, then we are just appending this tool to the visible list and returning to the agent. So in that way, we just achieved this. So for Alice, only the red tools are visible, and not visible or hidden are the rest of the prop and write tools. And second point, as I mentioned, we do the check using the decorator require scope with the proper MCP scope here. And during the execution of particular tool, we got this access token, preferred username just for logging. But here is the most important part is just if the required scope not in token scopes, then we are just returning the permission error, access denied, or some other, say, comments here. And if not, then we could execute the tools, which means that the required scope is in token scope of the user. So it is straightforward how we can achieve it, adding some code and properly marking for each tools and proper configuration of the scopes for user roles. So let's summarize. So identity is a foundation. So we demonstrated how JWT can carry useful information that could be used and must be used by MCP server. That MCP server that applies those checks in two, or say, moments. when tools lists are delivered and tools is executed. Of course, this access is aligned with the risk of particular tools. And a key takeaways for you. So we should not treat AI agent as just a clients. We should treat as particular identity to enforce privileges at the MCP-tool level that we demonstrated. Whenever possible, we should hide unauthorized tools and we should not rely on the same runtime checks, or we should not expect from our agent that's not the tools used that are not authorized. We should force that. Definitely, we need to always enforce these checks at the execution time. And it is good to point to just proper configuration of identity when we in fact model what particular role is allowed to do from which particular MCP servers. But of course, it needs to be aligned with the MCP server code and proper marking of tools. Okay, so this sums up the first part, and I highly encourage you to see other parts. You can find the links to the webinar and also to particular parts under this video, so you can just review all of the parts. So I highly encourage you to do that. In the next part, we will be talking about some problems with insecure MCP tools that may happen, and the need for device level security. So thank you for watching. The easiest way to contact our company is via email, contact@codilime.com. Thank you again for watching.